Hi everyone, it's Joanne. I hope you're all well. I am going to solve the first problem, which is 2.91. It's on page 65 in the textbook, and it is the first problem in homework number 4, which is on 3D resultants. You'll see it is a 3D problem. There's a x-axis, y-axis, and z. And you'll notice that the x and the y-axis make up the vertical plane, and the x and the z-axis make up the horizontal plane. And you can see that Q is up from the xz plane, and P is also up from the xz plane. So first I'm going to solve for the components of the forces, P and Q individually, and then I'm going to add those forces vectorially to get our resultant. So I'm going to start off with P and doing it using the 3-step process. P is equal to 300, and I'm going to put brackets here. And I'm looking at the x component, so I'm going to go down 30, cosine 30, and then I'm going over 15 plus 90, so it's cosine of 30. Cosine of 15 plus 90, which is 105, and that's I. Plus, now I'm going to the y direction, and the y direction is up here, so I'm looking at this distance right here from P to y. I'm trying to find what theta y is. And if I see that it's 30 degrees, if P is 30 degrees up from the xz plane, then theta y is going to be 90 minus 30. So it's going to be the cosine of 60j. Plus, now I'm going to the z-axis. I go down 30 and I'm going over 50. So that's cosine 30 times cosine 15, k, and the units that I know I'm given here are in newtons, so I'm putting newtons. Okay, then I'm solving for the magnitude and the direction angle. And the magnitude and the direction angle, hang on, I have it written down here on my notepad, turns out to be negative 0.2241I plus 0.500J. Notice unit vectors are always done in 4 decimal places, plus 0.8365K, and that's newtons, and then it comes out to be. And while I'm doing that, I might as well do the check here. 2241 squared plus 0.5 squared plus 0.8365 squared equals 1, and I check that out. Always make sure you do actually do the check. And then P turns out to be negative 67.2 I plus 150.0J plus 251.0K, and it's all in newtons. And since I want to represent the force in vector form, I'm going to just box it in, and then I'm going to do my magnitude check. And when I plug it into my calculator, I find out that it does come out to be 300, so it's okay. Okay, now I'm going to Q. Q is equal to 400 newtons. We're looking at going to the x-axis, so I have to go down by 50 and over 20. So that's cosine 50, cosine 20I, plus, now I'm looking at the y-axis. If it's here up 50, then this theta y is 40, cosine of 40j, plus, now I'm going to z. I go down 50, and then I have to go over 90 plus 20, so that's the cosine of 50 plus the cosine of 110, okay, and it's equal to newtons, and it comes out to be, and I'm using a calculator, 6040 I plus 7660J plus, nope, it's a minus 0.2198, okay, newtons, and I might as well do my check, 0.6040 squared, 0.766 squared plus 0.2198 squared, and it comes out to be 1. Great. And now Q turns out to be 241.6I plus 306.4J minus 87.9K, and it's in newtons. And I'm going to check the magnitude, 241.6 squared plus 306.4 squared plus 87.9 squared under the radical, and comes out to be 400. Okay, so you notice I did the unit vector check for both. I also did the magnitude check for both, but do you notice what I didn't do is I didn't do my plus and minus visual check. So let's take a look back at the picture. We're looking at P as being in the negative X, yes. It's in the positive Y, and it's in the positive Z. So my plus or negative visual check checks out. And now how about for Q? Q is in the positive X and positive Y, but it's in the negative Z. So the plus or minus visual check is good. Okay, next thing I'm going to do now is I'm now looking at my values of P and Q, and I'm going to find my resultant. My resultant vector is going to be equal to negative 67.2 plus 241.6. And this is going to be I plus 150 plus 306.4 J plus 251 plus minus 87.9 K, and all this is again newtons. And this comes out to be, let's see, 27. I gotta do the math. Okay. This one is going to be 0.4. 7 plus this is going to be 4. And then this one 30 is going to be 7. It's going to be 1. I plus 456.4 J plus, I'm going to have to do that one on my calculator, 251 minus 87.9 is clear. 251 minus 87.9. So I'm taking the number 251 minus 80. Come on. Bad calculator. 251 minus 87.9 equals 163.1 kips. And let me just check this first one. 67.2 minus 241.6. 174.4. Great. Newtons. And this is my resultant in vector form. But the problem also asks to do the force, the resultant force, not only in vector form, but also in magnitude and direction angle. So to find out the magnitude of R, I'm going to use 174.4 squared plus 456.4 squared plus 163.1 squared, all under the radical, and it equals, find that out in a minute. And then in order to find my direction angles, it's going to be the inverse cosine of the resultant in the x over the total resultant, cosine resultant y over resultant, and cosine of -1 of resultant z over resultant. And then I'll solve for that. Okay, I'm going to stop.